Okay, at this point, we will go over the grid and response from section 3. So, if x is greater than, number 16, if x is greater than 0, what is one possible solution to the equation above? So, in order to solve this, what I really want to do is try to get everything to one side. If I do that, I can first distribute here. And now the rule to remember with this one is you have to be able to remember when you multiply x's, you add up the exponents. So x cubed times x squared is x to the 5th minus 5x cubed. And then what I'm going to do is I'm going to add the 4x over to get everything to one side. So now what am I going to do is I'm going to try to see if I can factor this. Now, all of these have an x in them. That's kind of nice. So I take that x out. I'm left with x to the 4th minus 5x squared plus 4 is equal to 0. I can actually look at this and say, this looks exactly like a quadratic, except all the exponents are double. So what am I going to do? I'm going to treat it like a quadratic where all the exponents are doubled. That means I'm going to say this is x squared times x squared. And I have to remember what multiplies to 4 and adds to negative 5. Well, in that case, what multiplies to 4 and adds to negative 5? It'd be negative 4 and negative 1. And then I can set each of these equal to 0. I'm just going to use the space below this to finish this problem. I can say x is equal to 0. I could say x squared minus 4 is equal to 0. Then I could say x squared minus 1 is equal to 0. Now, I can't use x equals 0 because it strictly says x has to be positive. X has to be bigger than 0. So I can't use that one. Okay, what about the second one? Well, I would add the 4 over. And then I would square root both sides. And if you remember that problem earlier that we did, whenever we square root, we have to include a plus or minus. And what's the square root of 4? 2. We cannot include the negative because, again, x has to be positive. So get rid of that negative because x has to be positive. So one answer is x equals 2. Another answer is x squared equals 1. Square root both those, x equals plus or minus 1. Again, get rid of the negative because it says no negatives. So if you answered 1 or 2, that is acceptable. Okay? So you go ahead and either pause that, but I'm going to go ahead and erase that for number 17. So for number 17, we have 7/9 x minus 4/9 x equals 1/4 plus 5/12. And the best thing to do with this one is just say, I hate fractions, so let's get rid of our fractions. How do I do that? Well, I look at this and I say, okay, I'm going to rewrite this, just make it a little bit bigger. Fractions are just something divided by something. And how do I undo division? I use multiplication. So let's say I want to get rid of these 9s, because these 9s, there's 2 of them. What am I going to do? I'm going to multiply 9 by everything and literally distribute to everything. What does that give me? 9 times 7 is 63 over 9x minus 9 times 4 is 36 over 9x equals 9 over 4 plus, and then 9 times 5 is 45 over 12. Now, this might seem like I made this problem worse, but I did this intentionally because I know everything's going to reduce. For example, 63 over 9, that reduces to just 7x. 36 over 9 reduces to 4x. 9 over 4ths does not reduce. 45 over 12 does reduce. You can take a 3 out of both of those. 45 divided by 3 is 15. 12 divided by 3 is 4. That allows for a lot of nice things to happen. For example, I can combine like terms on this side and I get 3x. I can even combine like terms on this side and I get, let's see, 9 plus 15 is equal to 24 over 4, which that reduces to 3x equals 6. So therefore, x is equal to 2. Was my goal to find x equals 2, or was my goal to find something else like x plus 7 or something like that? No, it just says what is the value of x? So I would grid in 2. All right, for this one, number 18, two isosceles triangles are shown above. If if 180 minus z equals 2y, and y equals 75, what is the value of x? So I know in this picture, this angle right here is 75. I also know I could find z because it says if y is 75, I can plug that in there. So 2 times 75 is 150. So ask yourself this. You don't actually have to solve this. Just ask yourself this. What is 180 minus what equals 150? Well, obviously, z must equal 30. So that's this angle right here. That angle is 30. But I'm still not asking for what is y or what is z. I'm asking for what is x. So my thoughts are, if I could figure out this base angle, then 180 minus that base angle is x, right? So this is x, but this is 180 minus x. And I also know that this has to be the same because it is an isosceles triangle. This side and this side are equal to each other, so that this must be 180 minus x. So I know that 3 angles of a triangle add up to 180. So I'm going to say 30 plus 180 minus x plus another 180 minus x has to equal 180 because the 3 angles of a triangle always add up to 180. Now, I can automatically see one of the 180s cancel. How nice. What's left? 30 plus 180 is 210 minus 2x is equal to 0. So then how do I solve? I would add the 2x over. I would divide both sides by 2. And I get x equals 105. So the correct answer is 105. This is not the only way to do this problem. There's many ways to do this problem. I kind of just went about the approach of saying, oh, okay, I can make a quick equation here. I know there's another equation, and I can use all 3 together. That's how I come up with that. Again, all 3 angles, this, and this, are the ones that add up and give me a total of 180. All right, number 19. At a lunch stand, each hamburger has 50 more calories than each order of fries. Okay, I'm actually going to start writing an equation for that. So hamburger is going to be H, fries are going to be F. Now hamburger has 50 more calories than fries. So when I write these out, sometimes I'll write this out. Does H equal F? No, H has a lot more. So that means F needs help. It needs plus 50 calories to be equivalent. So if I add 50 more calories to the order of French fries, I'll get what every hamburger has. If 2 hamburgers, so 2 H's, and 3 fries, so 3 F's, total up to 1,700 calories, how many calories does a hamburger have? Okay, so what I'm going to do now is actually just substitution. I'm going to substitute this in for the H, because that's what H is equal to. So I get 2 times F plus 50 plus 3F equals 1,700. I'm going to distribute, so I'm going to get 2F plus 100 plus 3F is equal to 1,700. And then 5F plus 100 equals 1,700. 5F, if I subtract 100, it's 1,600. Now I have to divide by 5. Now most of you are like, this is too tough to do without a calculator. My hint, anytime you divide by 5, it almost has shown up at least once on the SATs. What you can do is you can double the top, which would be 3,200, and then move the decimal place 1 over, and that gives you 320. Now, that is actually not the correct answer. How come? Remember not to fall for the easy stuff like this. Okay, why do I say it's easy? Because it says how many calories does a hamburger have? Therefore, I don't actually care about the fries. I have to go the extra step, plug it back in. So hamburger is 50 more, so that's 370. Many people picked the wrong one, which was 320. Okay, final one. If triangle ABC, so I'm going to draw a triangle, and the measure of angle B is 90 degrees, so ABC, this is a 90-degree angle. If BC is 16 and AC is 20, Triangle DEF is similar to triangle ABC, where vertices DEF correspond to ABC. So I'm going to draw that out. And I should be drawing out the same order because it does say respectively. So that means DEF goes like this. And each side of the triangle is 1/3 the length of the corresponding sides of ABC. So that means this is 16/3. And this is 20/3. What is the value of sine of f? So this is where you have to remember SOHCAHTOA. I know it's been a while since you guys probably seen trig, but definitely need to know it. So I am looking at this angle f, right? Here's angle f. From this angle, opposite side is right here, adjacent side is right here, hypotenuse is right there. Sine is opposite of hypotenuse. So I would love to figure out this side. And if I got to figure out this side, I might as well just figure out this side. How do I find the third side of a triangle? I have to use Pythagorean theorem. Now, one thing I can say is, you know that this is one of the sides, right? And I might have something 16, 20. If this is in the no calculator portion, you're probably not going to have to do Pythagorean theorem if you remember your triples. So now you're going to think about your triples, for example, like 3, 4, 5, and 5, 12, 13, and 7, 24, 25, and say, can I use any of my triples for this one? Well, if I look at this one, I like the 3, 4, 5. Why? 3 times something, 4 times something, 5 times something. What can I multiply 4 and 5 by to get 16 and 20? I can multiply both of those by 4. And if I do that, I know that this is 12. So if this is 12, because of my 3, 4, 5 triangle, then this is 12/3, aka 4. Okay, but we're going to leave it as 12/3 because you'll realize why it's nicer that way. So now if I go back to the sine of f, this question, then I want the opposite over the hypotenuse. So I want 12/3 divided by 20/3. 3's can cancel. 12/20. And then how can I reduce? I could take out a 2, so that's 6/10. I could take out another 2, that's 3/5. So I'm looking for 3/5 as an answer. And again, make sure you guys box in or bubble in 3, and then the division symbol, and then 5.